Lesson 58, lead coefficients and completing the square. Okay, again, our terms are always very important. How would you define a coefficient? What would you say about it?
It accompanies like a number or a variable.
Yeah, okay. It's usually the number right in front of a variable. And when we call it the lead coefficient, that is going to be the one in a quadratic equation. You list the terms in descending powers, and the coefficient of your first term, the highest exponent, is your lead coefficient. All right. So more on completing the square. We've done this before, so it's kind of a review. But what are we adding to it this time? I don't know. So let's just talk about what we're doing when we're completing the square. We have some shortcuts and easy ways to factor and multiply. Factoring and multiplying are kind of the opposites, right? If we had x squared minus 9, we call that a difference of squares. Difference of squares, right? Pretty easy. And if you want to factor that, you take the square roots of each of those. What's the square root of x squared? X. Square root of 9. And you just add them and then subtract them. Boom. Easy. And the same goes the other way. If you wanted to multiply this, you would identify it as a difference of squares, and you could just say, oh, it's x squared minus 9. You wouldn't have to do the whole multiplying and simplifying and all that stuff. Okay, shortcuts. We are teenagers. Well, by we I mean you. And we love shortcuts, right? So another shortcut is if you have a square of something like x minus, well, let's say 3 even. We'll use the same exact number so you can see how they're different. X minus 3 times x minus 3, that's x minus 3. Another way to say that would be x minus 3 squared, right? Anything times itself is squared. So rather than doing this whole, multiplying, blah, 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 we know that the first term is x squared, the last one's going to be 9, the middle term's going to be negative, this one will be positive, and this is going to be double the product of the x and 3. So that's 3x, double it, we get 6x, okay? And this, because we want to know the names of things, right? Very important, is a perfect square trinomial. So that is what we're looking for. We're trying to make a perfect square trinomial. We call it completing the square, and it's going to come in handy later. We're taking all of these baby steps to graph different cubics and conics later. Conics? So, completing the square. Let's get right into it. Practice problem A. 3x squared plus 5x minus 6 equals 0. We can't factor that too quickly right off the top of our head, so we're going to complete the square. First thing that we need to do, and that's why that lead coefficient definition was important in the beginning, is we don't want any coefficient of x squared, so we're going to have to get rid of that. So the first step, and you can see all these steps listed in your book, the first step says to divide every term by the coefficient. So that means we're going to have a lot of fun, right? You can see that right off the bat because we're going to get some fractions in here. So we get now x squared plus 5/3 x minus 2. When we're completing the square, if we were to look at this perfect square trinomial, how do we get this term here? Well, it's half of that, right? Because we double it to get that middle term. So we take half of it, 3, and then what do we do to get 9? Square it. So we're going to do the same thing to make a perfect square trinomial. But first, this we need to get rid of. We're going to move that to the other side. So we get x squared plus 5/3 x. We're leaving this space open to complete the square, and we throw that 2 to the other side. So how do we find this term? The same way over here. We're going to take half of 5/3. Okay, so we bring that over here, 5/3. We're going to take half of it, and then what are we going to do to that whole thing? Square it. So half of 5/3 is 5/6, right? Square it, and we get 25 over 36. And remember, because this is the world of math, where everything is lovely and fair, whatever we do to this side, we have to now do to this side. So we simplify and solve. Here, the whole point was to get it to look like this. Okay, so how do we get this? We have now created a perfect square trinomial, so we're going to write it in its factored form, which would be x plus what? Remember, it's the square root of each of the first term and the third term gives us,
Would just be 5 over 6.
it would be 5 over 6. Yes! Equals, so we have to combine that, so we just have, doesn't reduce or anything, it's not very pretty, but 2, and, well, should we change that to 72 over 36, maybe? And then what do we get? 97 over 36? Is that a good idea? Yes, okay, great. Now, we have to solve this. Any ideas? And then we're gone, then we're done, probably overtime.
Yep.
So we have to do the opposite operation, right? We're keeping it simple. Opposite operation, what's the opposite operation of squaring?
Division.
Close.
Square root.
Square root.
Yeah.
So it becomes x plus 5/6 over here, and this, we love 36, right? Because we know our perfect squares. That, the square root of 36 is just 6. Square root of 97, we're just going to leave it like that. Are we done?
No.
Why? Because,
X is not by itself.
thank you. So to get x by itself, we're going to move that right in front, because that's just what we do. Okay, we're going to move it right in front there. And what happens when we move it over? It becomes negative 5/6 plus a root 97 over 6. But what I forgot when we did this here, when we are taking the square root of anything, like if we have the square root of 9, what is the square root of 9? Well, it could be 3, or it could be negative 3, right? Because negative 3 times negative 3 is 9. So that's what I should have done here. This should be a positive and a negative, which would make this positive and negative, and this positive and negative. So that's your final answer.
I want to meet the guy who created this problem.
He's dead, but maybe he's in heaven. Wouldn't that be nice?
I just want to make him feel bad. Tell him his cat died.
Oh my gosh, I thought you were gonna say you wanted to thank him. And we'll end on that note.
Perfect. Yeah, it's end on.